Good evening, everyone. My name is Maurya Hanspal, and in this session, I'm going to continue my previous session on some of the tools to analyze the market. So, this is the session number 3 on talking about some of the tools to analyze the market. So, in the previous sessions of 1 and 2, we discussed about a large number of tools to analyze our stock prices and basically our stock returns in the market. We took the data for a periodic time, and we had like certain prices of the stock, and we took the data for a 7-day period, and then we tried to analyze the stock prices. The prices have increased or prices have decreased, or the prices have moved in a phase of consolidation. Then we tried to find out the holding period return of those stock prices. We calculated the holding period return from those stock prices. Okay. And all the formulas, all the methods which I talked about in my previous sessions were applicable to all the data, whether it is a data of a 7-day period or a monthly data or an yearly data, or maybe the data for past 10 years or 15 years or 20 years even. All the formulas, the basic concepts and methods, it remained the same. So for the sake of simplicity, to make you people understand, I took the data for a shorter period of time. So we had the stock prices, which can be downloaded from any of the websites, be it the Bombay Stock Exchange or the National Stock Exchange. So after downloading the stock prices, we calculated the holding period return of those stock prices. And we compared the stock price of day 2 with day 1, then day 3 with day 2, day 4 with day 3, day 5 with day 4, and so on. And we got to know that how much return the stock has given us on the basis of the price, or the stock has lost its value. Then we also tried to calculate the holding period return not only on the basis of capital appreciation, we also took into the effect of dividend payments as well. Like if the company is paying dividend apart from capital appreciation, or even if the stock price has fallen and still the company has given the dividend, the method, it remains the same, right? Then we also talked about how to calculate the riskiness of the stock. By riskiness of the stock, we means the total risk of the stock, which is calculated by the standard deviation and the variance. Higher the standard deviation or higher the variance, it is one and the same thing. It means that the stock is more risky, right? Then we also try to calculate the average return of the stock or the mean return of the stock. जो हमारे पास stock के returns थे, so we took an average of all these, and we got to know that over a period of time, so what was the average return of those stocks, right? Then we also tried to calculate the measures of association, that was covariance, which shows just the direction, and also the correlation, which shows both the direction as well as the magnitude. So that we talked about, and we did some practical calculations upon that as well. And also we talked about the geometric mean, that what exactly is geometric mean and how is GM different from the arithmetic mean. That is GM, it takes into account the concept of compounding, whereas arithmetic mean, it does not take into account the concept of compounding. So that we try to understand. We talked about the measures of central tendency being the mean. We talked about the measures of dispersion, be it your standard deviation and variance. And we talked about the measures of association, your covariance and correlation in the market. So today, let's talk about like one last like measure of dispersion, and which is like a very small formula, like which was left in the previous session. Okay, that is known as your coefficient of variation. Your coefficient of variation. It is a measure of dispersion, okay? It is not a measure of association. It is a measure of dispersion. Because of lot of people confuse themselves because coefficient लिखा जाता है, and coefficient of correlation and covariance, and they tend to term it as coefficient of association. But when we talk about coefficient of variation particularly, to look at this part, because your measures of dispersions, like when I take you to the concept of statistics. So in terms of statistic, what is coefficient, or like what are the measures of dispersion telling you? They are telling you how much is a certain value away from the mean. कोई भी सर्टन वैल्यू है वो कितने स्टैंडर्ड डेविएशन दूर है फ्रॉम मीन. Basically, in other words, we can say कि it is telling you the variation or the variance, right? So coefficient of variation is a measure of dispersion. इसका बहुत ही सिंपल फॉर्मूला है, it is standard deviation by mean. That's it. We know how to calculate the standard deviation and we also know how to calculate mean. Okay. So calculate the standard deviation and calculate the mean and you'll have the coefficient of variation. Either in your exam they can give you the values of standard deviation directly and mean directly, or either they can give you the values कि मान लो कि स्टॉक रिटर्न्स दिए होंगे एंड उसका फिर स्टैंडर्ड डेविएशन निकालो, देन उसका मीन रिटर्न निकालो, देन वैल्यूज को पुट इन कर दो. एंड वो सब कैसे निकालते हैं, सो दैट वी हैव डन इन द प्रीवियस सेशंस. ओके, सो मोस्टली ऑल द कॉन्सेप्ट्स व्हिच आई वुड बी टेलिंग यू टुडे, okay, so I would be telling you some new concepts and some new formulas. Okay, but the derivation of those formulas and how to calculate the values in those particular formulas we have already done in the previous two sessions. So today I would be focusing more towards conceptual clarity and the new formulas that we learned today. Okay, so that was the coefficient of variation we talked about. अब एक चीज आती है, if someone says you calculate the unsystematic risk of the stock or the unsystematic risk of the market. Unsystematic risk is nothing but the risk which can be diversified away. It is a company specific risk. So if someone says you, like in the field of finance, calculate the unsystematic risk. Unsystematic risk means nothing than calculate the standard deviation. And how to calculate the standard deviation we have already done in depth in the previous session. So if someone is saying you calculate the non-diversifiable risk or calculate the undiversifiable risk, okay, so basically it is nothing but your systematic risk. That is the risk which can be diversified away. And non-diversifiable risk is also called the unsystematic risk or the non-systematic risk. Okay, so make sure of that. And this we have already discussed in the topics of capital structure. Okay, that what is systematic risk, what is non-systematic risk, and all the lectures are available on YT session of College Dekho, so people can go back after this session and watch that session. Okay, so if someone says you calculate beta, now beta is a measure of systematic risk or the non-diversifiable risk, the risk which cannot be diversified by the company, or a measure of market risk. Then how to calculate beta? Beta is a proxy of systematic risk as we call it in terms of finance. तो इसका फॉर्मूला क्या होगा? कोवेरियंस, एंड कोवेरियंस ऑफ रिटर्न्स बिटवीन योर स्टॉक, लेट्स टेक आई एज द स्टॉक एंड एम एज द मार्केट, डिवाइडेड बाय द वेरियंस ऑफ द मार्केट. ओके, so in this case we are not taking standard deviation here, like we'll be comparing two stocks. In covariance, those who have watched the lecture on capital structure, they know that beta is a proxy of systematic risk. वो बताता है कि कितना रिस्क आपके पोर्टफोलियो पे है ऑन द बेसिस ऑफ द मार्केट रिस्क. ओके, सो ऑब्वियसली अपने स्टॉक का रिलेशन विल ट्राई टू फाइंड आउट विद द मार्केट एंड नॉट विद एनी अदर स्टॉक, बिकॉज बीटा इज अ मार्केट रिस्क और सिस्टमैटिक रिस्क. तो अपने स्टॉक के रिस्क को विल ट्राई टू रिग्रेस इट ऑन द बेसिस ऑफ मार्केट. तो मार्केट एंड अपने स्टॉक का तुम कोवेरियंस निकालोगे, बिकॉज जब मार्केट रिस्क की बात आती है तो तुम दो स्टॉक्स के बीच का नहीं निकाल सकते. ठीक है, लाइक कोवेरियंस. ओके, सो बीटा इज अ मेजर और प्रॉक्सी ऑफ मार्केट रिस्क. तो जहां पे मार्केट की बात आई, यू हैव टू फाइंड द कोवेरियंस और रिलेशन बिटवीन स्टॉक के रिटर्न्स एंड मार्केट के रिटर्न्स, राइट. सो अगेन, जैसे हमने लाइक प्रीवियस सेशंस में करा था कि स्टॉक के रिटर्न्स दिए होंगे एंड मार्केट के रिटर्न्स दिए होंगे. सो कैलकुलेट द कोवेरियंस बिटवीन द टू, राइट, देन कैलकुलेट द वेरियंस ऑफ द मार्केट. All the process remains the same as we calculated in the previous session. Okay, so I'm not emphasizing on the whole calculation part once again, because all those calculations we have done clearly in the previous session. So this session gonna be more about concept and formulas. हम covariance निकालना हमको पता है कि how do we find covariance, we know like how do we find variance. And denominator में you just have variance of the market. ठीक है, variance of stock नहीं है, variance of market है. Okay, so if someone is saying you calculate the diversifiable risk, okay, then calculate the standard deviation. If someone is saying you calculate the non-diversifiable risk or systematic risk, calculate beta. because beta is a proxy of market risk. Okay, that thing we need to understand. I'll just erase this as well. Now I'll be talking about one of a major concept which everyone should know here. And those of you who do not understand what I am telling you right now, go back and watch all my lectures on capital structure, because this is something we have derived from capital structure. Okay. So in capital structure, like what did we do? We talked about the concept of efficient frontier, market portfolios, systematic risk, unsystematic risk, capital allocation line. All these things we talked about. And efficient frontier was a C shaped curve, and यहाँ से ये कट होके एक लाइन जा रही थी ऊपर, ठीक है, which was the capital market line or the capital allocation line, तुम जो भी बोलो इसको. Okay, here you had the standard deviation or risk, and here you had your expected return. ठीक है, तो हमने इसकी बात करी थी, and we talked about this in detail कि capital market line क्या होती है and efficient frontier क्या होता है. So you people can go back to the capital structure recordings and watch that. Like deriving from this concept, okay, we have something which is called as the global minimum variance portfolio. Global minimum variance portfolio. We also call it as GMVP. GMVP. It is a global minimum variance portfolio. So as the name suggests, it is a kind of portfolio which has minimum variance. Means a portfolio जिसमें बहुत सारे stocks हैं, but risk उसका बहुत ही कम है. The risk is minimized. कम से कम risk है. Okay. So in global minimum variance portfolio, our emphasis is on lowering the risk to the maximum extent. इस पे हम रिटर्न पे ज्यादा फोकस नहीं करते. We're just concerned about कि रिस्क को हमें मिनिमाइज करना है. एंड रिस्क हमें कैसे मिनिमाइज करना है? बाय गिविंग एप्रोप्रिएट एलोकेशन टू स्टॉक्स इन योर पोर्टफोलियो. हो सकता है तुम्हारा पोर्टफोलियो है एंड मान लो उसमें 4 स्टॉक्स हैं ABCD. ओके, तो इट इज नॉट मैंडेटरी that you would be allocating 25% of weightage to A, then 25% to B, then 25% to C, and 25% to D. So it's not mandatory that you would be allocating equal percentage or equal weightage to all the stocks in the portfolio. It can happen that stock A is a very strong company, the strongest company in your portfolio, and to that you allocated 40%. B के लिए 20% you gave, C के लिए 10%, and remaining 30% you gave for D. Okay, so these allocations can differ. So global minimum variance portfolio, it helps us to understand how much weights we must assign to those particular stocks in the portfolio. कि stocks को कितनी हमें मतलब कि weightage देनी है ताकि हमारे portfolio का risk can be minimized. It can be as low as possible. So that the global minimum portfolio it stresses upon. And then how to calculate the weights for that? See, for that, first you have to calculate the correlations. Okay, if the correlation is coming -1 or 0, अगर 4 स्टॉक्स हैं तो 4 स्टॉक के बीच की कोरिलेशन निकालो. अगर 2 स्टॉक्स है तो मतलब कि 2 स्टॉक के बीच की तुम कोरिलेशन निकालो. 10 स्टॉक हैं तो 10 स्टॉक के बीच की कोरिलेशन निकालो. And that can be performed very well on Excel. And how to do all this on Excel, I'll keep a separate session for that, so not to worry. ठीक है, तो अगर आपकी कोरिलेशन की वैल्यू -1 और 0 आ रही है तो वेट ऑफ स्टॉक क्या हो जाएगा? मान लो अगर 2 स्टॉक्स हमारे पोर्टफोलियो में, तो इट वुड बी द स्टैंडर्ड डेविएशन ऑफ स्टॉक B डिवाइडेड बाय द स्टैंडर्ड डेविएशन ऑफ A प्लस स्टैंडर्ड डेविएशन ऑफ B. अगर हमें स्टॉक A का वेट निकालना है तो न्यूमरेटर में फर्स्ट विल हैव द स्टैंडर्ड डेविएशन ऑफ B. स्टैंडर्ड डेविएशन ऑफ A नहीं आएगा, ठीक है. स्टैंडर्ड डेविएशन ऑफ B divided by the standard deviation of stock A plus standard deviation of stock B. Then how to calculate the standard deviations we have already done in the previous session. तो ये फॉर्मूला यूज करने से पहले देख लेना कि कोरिलेशन या तो -1 हो या 0. This formula is only applicable when the correlation is -1 or 0. But अगर correlation is perfectly +1, then this formula ranges इसका चेंज हो जाता है. It becomes तो स्टैंडर्ड डेविएशन ऑफ ए माइनस स्टैंडर्ड डेविएशन ऑफ बी, साइन का चेंज आ जाता है, ठीक है। तो जब वन होगी लाइक कोरिलेशन, देन ओनली लाइक यू कैन यूज दिस फॉर्मूला। And then how to calculate the weight of B? It would be 1 minus the weight of A. Basic maths. 1 minus the weight of A. तो ये सेम रहेगा, ठीक है। अब क्वेश्चन आते हैं माइंड में, अगर लाइक कोरिलेशन -1 या 0 है तो वी आर यूजिंग लाइक दिस फॉर्मूला, ठीक है। तो इस चीज को याद रखना, -1 और 0 वैल्यू है, सिर्फ -1 वैल्यू होनी चाहिए या सिर्फ लाइक 0 वैल्यू होनी चाहिए। एंड इफ यू वांट टू कैलकुलेट द वेट ऑफ ए, फॉर्मूला ये वाला होगा, फर्स्ट वाला। बट अगर कोरिलेशन +1 है, इट इज परफेक्टली पॉजिटिव कोरिलेटेड, देन फॉर्मूला विल चेंज टू दिस, ठीक है। अब क्वेश्चन आता है कि अगर कोई और वैल्यू आ जाए, मतलब मान लो कोई बीच की वैल्यू आ जाए, राइट, कि 0.5, 0.2, 0.9 या -1.2, -1.5, ठीक है। सॉरी, मतलब कि -0.9, -0.8 से लेकर +0.9 तक कोई वैल्यू आ जाए एक्सेप्ट 0, तो इसके लिए हम क्या करते हैं, मान लो कि -0.9 से लेकर लाइक +0.9 तक कोई वैल्यू है, एक्सक्लूडिंग जीरो बिकॉज 0 के लिए लाइक वी हैव फॉर्मूला। तो उसके लिए योर फॉर्मूला चेंजेस। इफ यू वांट टू कैलकुलेट द वेट ऑफ ए, इट गोज योर वेरिएंस ऑफ बी minus the covariance of stock A and stock B, then your variance of A plus variance of B minus 2 into covariance of A and B, ठीक है। एंड वेट ऑफ B कैसे निकालोगे, इट वुड बी नथिंग बट 1 minus the weight of A. So this is a lengthy formula, like you can note down this formula and try to remember it if you can. Because if like you would practice this on a daily basis, then both these formulas, like all the three formulas, would be just a cakewalk for you. Okay. So how to calculate the variance of stock भी हमें पता है, ठीक है, कि like हमारे पास मतलब कि रिटर्न्स होंगे, देन उसका हम स्टैंडर्ड डेविएशन एंड वेरिएंस निकाल लेंगे। हाउ टू कैलकुलेट द कोवेरियंस बिटवीन टू स्टॉक्स, वी नो इट। वेरिएंस कैसे निकालना है, एंड इसमें जो कोवेरियंस की वैल्यू आएगी बस 2 से मल्टीप्लाई करना है। So once you have this value, so that would be the weight of stock A. And मान लो ये फॉर्मूला से तुम्हारा आंसर आया 0.6, ठीक है। तो वेट ऑफ B कितना हो जाएगा, 1 minus 0.6, that is 0.4। मतलब पोर्टफोलियो में 60% स्टॉक A होना चाहिए एंड 40% स्टॉक B होना चाहिए। सेम यू कैन डू दिस फॉर एंडलेस नंबर ऑफ स्टॉक्स, okay, for endless number of stocks you can do this, okay. So this formula tends to be quite complicated, but if you are like understanding this formula and doing it on a daily basis, it would be like very easy for you, ठीक है। तो जब हम बात कर रहे थे अपना इसका CML and like global minimum variance portfolio, so global minimum portfolio, we can say it as a starting point of the efficient frontier. As the starting point of the efficient frontier. Why? Because this portfolio has the minimum risk. And जैसे जैसे हम efficient frontier के towards जाते रहते हैं, हम market portfolio तक पहुंचते हैं, then फिर आगे बढ़ते हैं, तो risk बढ़ता जाता है. The risk increases. Okay? That is why we can say your global minimum variance portfolio is the starting point of the efficient frontier. And obviously the point of intersection of the indifference curve and the utility curve is your efficient frontier. So that is something different. तो इसके लिए मतलब कि capital structure की recordings देख लेना. But if someone asks you that what is the starting point of the efficient frontier, it is the global minimum variance portfolio. So that you need to understand. And CML, CAL क्या होता है, तो इसका difference we have talked in the previous sessions of capital structure. So make note of that. So in the next discussion on tools, I would be starting with talking about like more advanced tools to analyze the stock returns, like Sharpe ratio, Tenor ratio, Sortino ratios, and you have the tracking error. So all these things I would be talking about in detail in the next one. Okay.